Hey guys, we are in lesson 8-3, factoring with complex numbers. We are on page 132. Just a quick review from the last video. We talked about complex conjugates. Remember, complex conjugates are where we have a complex number and then its conjugate would be the opposite imaginary term. So notice if we have 3 plus 2i, its complex conjugate would be 3 minus 2i. Notice the imaginary terms are opposite. So today we're going to use that knowledge of complex conjugates to help us factor the quadratic equations and also solve quadratic equations. So those are our two learning objectives for today. So from yesterday with complex conjugates, this was a definition that we wrote down in lesson 8-2. So you could have any number for a and b here, but basically if you have a plus bi, its conjugate would be almost exactly the same, except the I is opposite, that I term. So instead of a positive BI, we have a negative BI. So what happens when we FOIL or do the box method is that the I ends up canceling, and we're left with an I squared, but we remember from yesterday, I squared equals -1. So really everything just cancels out to a real number. The I's go away. It's no longer complex anymore. It's just real. So the relationship between complex conjugates is that we get a real number. This can also be referred to as sum of two squares. You may remember difference of two squares when we were factoring with real numbers. So we also have sum of two squares, which is a squared plus b squared. So we're going to do some examples with factoring complex. Before we start factoring complex, let's just quickly review factoring in general. Always make sure you check for the GCF first. It's always step one. And then after you factor everything, once you get your factors, you can then find x values if needed. But once you get factors, make sure you check. Plug it back in, do box, FOIL, whatever method you want. Check to make sure you get what you started with. So let's look at this example. We have 16x squared minus 25. Notice this is a difference of two squares. Difference because of subtraction, two squares, because notice 16 is a perfect square, 25 is also a perfect square. You can take the square root of 16 to get 4, square root of 25 to get 5. So that means our factors are a 4x plus 5 and a 4x minus 5. Notice there's no imaginary term here because this is just a regular real number factoring example with difference of two squares. So let's look at an example where we are not dealing with real numbers. We have a sum of squares. So that's this example right here in part A. This is an example of sum of two squares. We know it's sum because of the addition, two squares because we can take the square root of 16 and 25. So let's do that. Square root of 16 we know is 4. Square root of 25 is 5. So if we remember back up here, this first term is like our a squared term. The second term is that b squared term. So its factors are going to be 4x plus 5i and then 4x minus 5i. The 4 gets the x because remember that this was a 16x squared, so square root of the 16 is the 4. A square root of x squared means that they both get an x. The positive 25. Okay, I think this will make a little bit more sense if we start with these factors and check. So let's FOIL these. Let's do first, outer, inner, last. Or if you prefer the box method, you can do that as well. So notice when we do 4x times 4x, we will get 16x squared. Then 4x times negative 5i would be negative 20xi. 5i times 4x is a positive 20xi. But notice all that really did was we got two opposite terms. So that inner and outer term just cancel out. So we really just care about the first and the last. So then last, Positive 5 times negative 5 is a negative 25. I times I is I squared. So you may be thinking, wait, even though we cancel, we still have that I right here. But notice this is not just an I, it's an I squared. And we know that I squared equals a value. It equals negative 1. So what we have here is 16x squared. And then right here we had negative 25 times a negative 1. Negative 25 times a negative 1 is a positive 25. Notice that checks out with what we started with. So let's try another one. Now, our first step, remember, is always check for a GCF. I kind of skipped that step in this problem because there wasn't a GCF other than 1, but that really should always be our first check. And again, in this step, this example, we did not have a GCF, so we didn't have to worry about it. So let's look at part B. Let's see if there is a GCF, if there's something we can divide 36 and 100 by. Well, if you list all the factors or just start plugging in numbers, you will eventually see that a number that 36 and 100 have in common is a 4. So if we factor out a 4, so that's our GCF, or greatest common factor. If we factor out that 4, divide them both by 4, we're left with 9x squared plus 25y squared. Just bring down the variables. Don't worry much about the x squared and the y squared. Just bring them down. So 36 divided by 4 gave us the 9. 100 divided by 4 gave us the 25. Now, let's just focus on what is inside the parentheses. That 4, that GCF that's out in front, just going to hang out there. So this is a sum of squares. Sum because we're adding squares because we can take the square root of 9 and the square root of 25. Those are both perfect squares. Okay, so square root of 9 is 3. Square root of 25 is 5. So notice when we take the square root of 9, we get 3, and the square root of x squared is an x. This is a 3x. So then right here, we took square root of 25 is 5. Square root of y squared is y. But since we're doing sum of squares, we will always have an I. So this is not just 5y, it's 5y I. And these are going to be complex conjugates of each other. So 3x minus 5yi. Don't get hung up on those extra variables and stuff. And then again, there's that 4 that's out in front that kind of ran into my other problem, but that's okay. So now that we have those factors and also that GCF out in front, let's check. Let's make sure this makes sense. So FOIL or do the box method for the factors. So just leave that 4 out in front for a little while. We will multiply everything by 4 at the end. So I'm going to FOIL. So we have 9x squared. Remember, when I do the outer and the inner terms, because these are complex conjugates, they end up canceling. So really I just need first and last when we're dealing with complex conjugates and these imaginary numbers. So we have 5 and negative 5 is negative 25. Y times y is a y squared. Okay, and then I times I is an I squared. And again, all there's that just 4 out in front. So I know it doesn't look exactly like what we started with, but we're getting close. We see an I squared, so there should be alarm bells going off in your head. I squared is negative 1. So right here, this is really just a negative 1. So that means we're doing negative 25 times negative 1. Well, that would be a positive 25. So it's 9x squared plus 25. Then we just have that y squared hanging out with it. That 4 is in front. So this last step is just to distribute that 4. Multiply it back in. So when we do 4 times 9, we get that 36x squared. 4 times 25 is 100, y squared. Notice we got back what we started with. We checked it. So now that you've seen a couple examples, I want you to try one. I want you to try part C down here. It's a little bit easier. Make sure you start with a GCF. See if there's something you can divide both terms, and then do the sum of squares.